Good afternoon, everybody. In this video, we're going to calculate the acceleration due to gravity on the moon surface. So what is given is the average density of the moon and the radius of the moon. That's all the numbers we know. From these two numbers, we're going to find out what is the mass of the moon and what is the acceleration due to gravity. So let's write down the given information. So the density of the moon is given 3,340 kilogram per cubic meter, and rho, this is pronounced as rho, and this one is a symbol for the density. R is the radius of the moon, and we need to find out the mass and acceleration due to gravity. So let's find out the mass. So what is the density? So if you have studied in your high school, the density, the physical density means mass per unit volume. So there is equation for this one. The density is simply given by mass per unit the volume. So I can solve for the mass, and the mass would be density times the volume. And now the question is, how do you find out the volume of a moon? So if you look at the moon is a sphere. This is a sphere. And what is the volume of a sphere? If you know the radius, what is the volume? The volume would be given by this equation here, 4 over 3 pi r cube. That's the volume of a sphere. So I'm going to plug in the equation for the volume, and we know all the numbers here. The density is already given. So let's plug in the density, 4 over 3 pi, and radius is given here. That's the value. So if you plug in and solve, this is the number you get. That's the mass of the moon. And now, once we calculated the mass, let's calculate the acceleration due to gravity. So the equation you need to remember is, for calculating the acceleration due to gravity, is this equation. You have to remember this equation. G m over r squared. What is G? G is a universal gravitational constant. Remember, G is universal gravitational constant. Gravitational constant. And why do we call it a universal? Because this value is the same everywhere in the cosmos. Okay, and m is the mass, which is given, and r, which we just calculated, and r is the radius of the moon. So if you plug in all the values, this is the value we get. That's the value on the moon surface. Okay, that's the acceleration due to gravity on the moon surface. Now if we compare acceleration due to gravity on the moon surface and on the earth surface, what do you get? So on the moon we have 1.59, and the earth we have 9.81. So if you solve it, the ratio we get is 1 over 6.16. So what does this number tell you? That means if you measure your weight on the moon surface, and let's say it is 100 Newton, then your weight on the earth surface would be 660 Newton. That is about a factor of 6.16. And I'm saying here is the weight, not the mass. The mass would not change. The only thing that would change is the weight. That is, the weight would change, not the mass. Okay. So and because the acceleration due to gravity is 1.59, it's about 6 factor smaller than the earth surface. If you jump, you would jump way higher on the moon surface compared to the earth surface. Okay, so this is it from this video. If you have any questions, write in the comment section below, and do not forget to like, share, and subscribe the channel. Thank you very much.